Mathematics, Analysis and Approaches, Paper 2, Timezone 1, HL, November 2025. This is question number 7 of 7 marks. This question is based on probability, mainly binomial distribution, and we are also going to be using the concept of Bayes theorem in this. The question says that there are two machines, which is machine A and then we have machine B, and both of them are manufacturing some kind of a semiconductor. And machine A has probability of 10% or 0.1 of manufacturing a defective semiconductor, and machine B has 0.05 probability of manufacturing a defective semiconductor. A randomly selected machine manufactures 10 semiconductors, and both machines are equally likely to be selected. So I'm choosing one of the machines, and in that I'm supposed to find what's the probability of exactly 2 semiconductors being defective, and given that exactly 2 are defective, find the probability that they were manufactured by machine A. For part B, we're going to be using Bayes theorem. Now let's understand part A. Part A can be done in 2 different ways, and I'm going to do both of them and tell you which is the right approach, because both the methods will give you approximately the same answer. When we are trying to apply binomial distribution, we have to check for certain conditions. Is the random experiment having only 2 outcomes? In this case, yes. One is that it's manufacturing a defective and a non-defective item, and therefore there are only 2 options. And then I'm going to check if the probability of success is always going to be the same. So that is also true, because manufacturing of a defective semiconductor is going to be 10%. And if the first one has been defective, doesn't mean that the next one will not be defective. So they're not dependent. They're going to be independent. And the number of trials is something that I'm looking for. And here the number of trials is going to be 10. So all the requirements for applying binomial distribution is satisfied. Countable. So let's make a tree diagram. So what I'm going to do here is to calculate the probability of defective. The probability of defective is otherwise a total probability. So that can simply be calculated as probability of choosing machine A into probability of defective given that it's machine A, plus probability of choosing machine B into probability of defective given that it's machine B. So I've used conditional probability here. So this is going to be 0.5 into 0.1 plus 0.5 into 0.05. Now that I have calculated the probability of an item being defective or one semiconductor being defective, the goal is to find out what is the probability of 2 semiconductors being defective. So finding out 2 semiconductors defective out of 10, that's what I'm trying to calculate. So I'm going to say probability of the random variable x being equal to 2 is simply 10C2 into defective, which is 0.075 raised to the power of 2, and non-defective, which is 1 minus 0.075 raised to the power of 8. I'm going to quickly calculate this. All right, now after finding this out, I will be proceeding to find out the value for now this, which is part B. So this is one way of approaching part A. The other way of approaching part A is to take the same tree diagram where I'm calculating the probability of choosing machine A and machine B. That probability is still going to be 0.5, and it is going to be 0.5. Whereas when I'm calculating defective, I'm going to calculate defective for 2 items, okay, directly, and not defective for 2 items, of course. And here I'm going to be calculating defective, but for 2 items together. All right. So earlier my probabilities, if you can see, was 0.1 and 0.05. But here I'm going to be applying binomial distribution to calculate this probability. So what is this probability going to be? 10C2 into defective, which is 0.1 raised to the power of 2 into 0.9 raised to the power of 8, of course. So let's calculate that probability. Let me do the same thing for this. So this is 10C2 into the probability of defective is 0.05 raised to the power of 2 into 0. Whatever this value is, 0.95 raised to the power of 8. Quickly calculating that. And we're going to get that 0.076746. Now, when I'm doing this calculation, which is 0.5 multiplied with 0.1937 plus again 0.5 into 0.0746, which is the same as this one, total probability. Okay, so let's quickly go ahead and calculate this value. You see that I get the same value, approximately the same value. The earlier one was 0.35, and in this case, I get a 0.34. Okay. Right. Now the question is, which method logically is correct? Because both of them give me almost the same answer. There's 0.01, value change. The logical method will be the second method. Though the first method is making sense and giving me approximately the same value, I would go with the second one. The reason being, you can see here, the situation is clear to us. There is machine A, machine B, and manufacturers 10%, manufacturers 5% defective. But when I'm choosing the semiconductors, I'm choosing it from either machine A or machine B. Okay, and therefore I will need the defective of machine A and machine B, two defective of machine A and two of machine B. In the first case, what I did was to consider that I've chosen 10 semiconductors. It could be from either machine A or machine B. Now that's the situation. Whereas in the second condition, I'm thinking that these 10 are coming from one particular machine. Okay. A randomly selected machine manufactures 10 semiconductors. So he's choosing one of them. And that is why this method would not be logical. Though it is giving me the same answer, this would be more logical to choose, because this is what is giving me the right answer. And this is the answer your mark scheme also would have, which is 0.937 and 0.0746. Given that exactly two semiconductors are defective, find the probability that they were manufactured by machine A. So for this, I'm going to use the second method answer, which is the same, 0.134. So the question says, given that the semiconductor was a defective semiconductors, okay, both of them were defective, what is the probability that it was manufactured by machine A? Now that's a question that we have. And how do we approach this? We simply reciprocate it. We say probability of defective given that it's A, machine A into probability of machine A, and that's divided by the total probability of being defective. And the total probability of being defective I've already calculated, which is 0.134, right? 0.134 is something that I've already calculated. I'm going to use defective given that it's A. So for that, I'm going to say 0.1937 multiplied with 0.5, and that's divided by this much. And that gives me a 0.7228. I can write it as 0.722. All right. And this is for 3 significant figures. And that's your solution for the question. Thank you.